All right, so today we're going to finish up chapter 4 by talking about similar figures and similarity transformations. So first thing we're going to do is introduce a new idea called similar figures. Similar figures have two main properties. So if two figures are considered similar, their corresponding angles have to be congruent. So for instance, in the triangles at right here, the corresponding angles, or the angles that match up, B would have to be congruent to F. So those two angles would have to be identical. A would have to be exactly the same as E, and then C would have to be exactly the same as G. So if these are going to be similar, all the angles are going to be identical. The other thing that has to happen is corresponding sides have to be proportional. So if we want to talk about proportional, what we mean is that it has a scale factor. So every side gets multiplied by 2, or every side gets cut in half. So for instance, if I said AB was 12, AC was 8, and BC was 14. And then in the other triangle, if I said EF was 24, EG was 16, and FG was 28, well, if we look at the corresponding sides, 8 times 2 would give me 16, 12 times 2 would give me 24, 14 times 2 would give me 28. So if all three sides increase or decrease by exactly the same amount, the sides are considered proportional. Now the symbol for similarity is just this kind of like little squiggly line. So off to the side here, you can see triangle ABC is similar to triangle EFG. That's what that statement means. And so just like before with congruent figures, similar figures tell you exactly how things match up. So right now they're saying angle A has to match up with angle E. Angle B has to match up with angle F, and so on. So the order of the letters is going to make a huge difference because it tells you exactly what's supposed to match up. Now, as far as calculating scale factor, we talked about that in the last section. So for scale factor, remember we take the image value and divide it by the pre-image. Now this can be any value. It can be a length of a side, it can be a coordinate, anything that has anything to do with a numeric value for the figure. So if we're looking for the scale factor of triangle ABC and triangle A prime, B prime, C prime. So A prime, B prime, C prime is the image, ABC is the pre-image. So what I could do is I could notice that BC and B prime, C prime are vertical lines, which means I can count to find their length. So I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's my image length. So I put image on top. And then I can count down from BC, which is 1, 2, 3, 4, 5. And so we have 10 over 5, which would be a scale factor of 2. That makes sense because in our discussion from the last section, A prime, B prime, C prime was bigger, which means we had an enlargement, and so my scale factor should be larger than 1. Now, that's not the only thing I could have done for that particular problem. If you notice, we have our coordinates here labeled as well. And so if we use coordinates, we can also get our scale factor that way, again with image over pre-image. So pick any one coordinate from the image. So for instance, maybe I pick the -4 here. Well, if I pick -4, that goes on top because it's the image. And then if I pick its corresponding part, so for -4, that's the x on A prime, I need the x on A. And so I put that in for my pre-image, and now -4 over -2 gives me a +2. And that would work for any of the coordinates. So you can do anything with lengths or coordinates to calculate that scale factor as long as you do image over pre-image. Same thing with the reduction. So for triangle ABC and triangle A prime, B prime, C prime, if I want my scale factor, we have image over pre-image. And so A prime, B prime, C prime is the image. I have a horizontal line, so I could count 1, 2, 3, 4. So then as far as my scale factor, image is 4. And then for my pre-image, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I go 4 over 12, which reduces down to 1/3. So in this case, a reduction should have a scale factor smaller than 1, which is exactly what we get there with 1/3. And again, I could have also used coordinates. For instance, B prime, the x value is 1. So there's my image. And then the corresponding x value would be 3. And so I still get the same scale factor of 1/3. So you can use lengths, or you can use image and pre-image points to calculate that scale factor. Now, when we're trying to determine if figures are similar or not, basically what we look at is if all the sides have exactly the same scale factor, then they're going to be similar to each other. So if I match up corresponding parts, for instance, 5 would match up with 10. So in this case, they don't dictate which is image and which is pre-image. So all we have to make sure that we do is we go the same direction each time. So I'm going to put the 5 over the 10. And so if I sit over here, I'm going to go 5 over 10, which would reduce down to 1/2. And then I'm going to pick 2 other corresponding parts. So 4 would correspond to 8. I go the same direction. So I'm going to put 4 over 8, which reduces to 1/2. And so then I keep proceeding, and I pick my next points, 3 and 6, and I'm going to put 3 over 6. We go the same direction all the way through. So 3 over 6 becomes 1/2. And if we notice then, all 3 scale factors were identical. They all came out to be exactly 1/2. And so what we'd say here is triangle ABC is similar to triangle. And now I got to be careful here. I started with A, which is going to match up with D. So then I start with D. B matches up with E, so I go E next, and then C matches up with F. And so the triangles are similar because all 3 sides were exactly proportional. Now if we look at this next figure, and we kind of start going through the same process, so in this case I start matching up pieces. I go 2, which matches up with 10, and again I'm just going to go same direction, 2 over 10, which would reduce down to 1 over 5. And then when I pick my next set of sides, I have a 1 matching up with my 4, go the same direction. And so I have 1 over 4, which doesn't reduce. And so if I look at this, these two are not the same. I've got a 1 over 5 and a 1 over 4, so that means these are not similar. So all 3 sides have to come out to be exactly the same thing for that similarity to work. Okay. Now for similarity transformations. So if we want to actually perform similarity transformations, what's going to happen is we're going to have some type of dilation or a dilation mixed with another type of transformation, like a translation or a reflection. So in this case, all you do is you simply take one transformation at a time. So for instance, if I wanted to graph triangle G or FGH, F is located at 1, 2, so I go right 1 and up 2. There's going to be F. G is at 4, 4, so I go right 4 and up 4. So there's G. And then H is at 2, 0. So I've got F, G, and H. And here's my original triangle. Okay. Now, the first thing it wants me to do here is it wants me to reflect across the x-axis. So if I'm going to reflect across the x-axis is this one right here. So I highlight that line. And so what's going to happen now is I'm going to reflect. And so H is actually going to stay exactly where it's at. So that's going to be H prime right there. F is currently 2 units above the x, so I'm going to go 2 units below the x. And there's F prime. And then G is currently 4 units above, so I'm going to go 4 units below. And there's G prime. And so then I connect my dots. And there's my first image. So I've done the first transformation of reflection. Now from here, let's take a look at where these points ended up. So I already had F, G, and H. So F prime ended up at 1, -2. G prime ended up at 4, -4. And H prime ended up at 2, 0. Now, if I'm going to dilate, we talked about this in the last section for dilation. So when I want to find F double prime, G double prime, and H double prime, they're giving me the rule right here. They're saying take all your x, y values and multiply them by 1.5. So for F double prime, I'm going to take 1 times 1.5, and so I'm going to get 1.5. -2 times 1.5 would give me -3, and so there's F double prime. G prime was at 4, -4, so when I multiply those both by 1/2, or 1.5, 4 times 1.5 is 6, so I would get 6, -6. And then 2, 0 would become 3, 0 when I multiply by 1.5. And so in this case, I'm going to choose a different color here. When I plot these new points, so f prime is at 1.5, negative 3. So we go right 1.5 and then down 3. So we're somewhere right in here. There's f double prime. Then we have 6, negative 6. So we go right 6 and down 6. And there's g double prime. And then we have 3, 0, so we go to the right 3, and then up and down, so there's g double prime. And then again, we just kind of connect the dots. And so then there would be our final image, f double prime, g double prime, h double prime. And then we have the coordinates right there listed out. So you're just taking one transformation at a time, just like we did with the congruence transformations. Now we're just adding dilations, and so that's just multiplying the points by a certain value. You also need to be able to describe similarity transformations, so being able to tell me how do I get from one to the next. So they're saying describe a similarity transformation that takes PQRS to WXYZ. So this PQRS is going to be the pre-image. We want to take it to WXYZ. And so when we look at that, they're telling us exactly what has to match up. P has to match up with W, Q with X, R with Y, S with Z. So if we look at what's going on here, they look like essentially mirror images of each other, and then WXYZ is just smaller. So if I want to figure out what's going on here, I can set up a transformation. And so my first move, if you notice on the right here, the first thing I'm going to do is I'm going to reflect quadrilateral PQRS. So I'm going to reflect across the y-axis. So what you're going to be doing is you're going to be telling me what rules you followed. So the first thing we're going to do is a reflection. So we record a reflection, and then we're going to say across the y-axis. So you just have to tell me what you're going to reflect across. So that's step number one. Step number two then, when we take our PQRS prime, so now we have the new red figure here. So once we're here, we need to get it to shrink down to WXYZ size. And so from here, again, we can kind of do a couple different things, anything with length, anything with points. We have a vertical line that we can count, WZ here. WZ has a total length of 2, and it would match up with P prime S prime, so I can count that, which would be 1, 2, 3, 4, 5, 6. Now, we know this is a dilation, so the next thing I do is I say we have a dilation. And now I need to give the rule. So what did I do to X and Y to perform that dilation? And so that's where the scale factor comes in. So when I want to shrink down to WXYZ, my scale factor is image, the 2, over the pre-image 6, because I'm going from red to green. And so if I reduce that down, it gives me a 1/3. So all I do is I take that scale factor and multiply it by X, and then take that scale factor and multiply by Y, and here are my two rules. If I reflect across the X, if I reflect across the Y and then dilate by 1/3, we're going to end up where we want to be. Okay, so with that, you should be able to work on the assignment for the day, which is a worksheet. Again, if you have questions on anything, make sure you ask in class, email, or check the answer key when it becomes available. But you should be able to perform pretty much any of the questions we went through in the notes here. So make sure you ask if you have any questions.